Hello, my name is Jason Bajan, and this is my presentation on the circumference and area of a circle for College Mathematics, period 1407, dated 7/27/2014. The circumference of a circle is the perimeter of the circle according to our Alex ebook, section 8.7, page 532. Imagine a fence sitting atop the edge of our circle. The length of this fence would be our circumference. The formula for finding the circumference is C equals pi times d. The area of a circle is the portion of space covered by the circle. Our textbook defines area as the number of square units that can be enclosed within a region. This is in section 8.7, page 534. The formula for finding the area of a circle is A equals pi times r squared. This looks great, but what do those letters mean? And what is that squiggly symbol we call pi? In the formulas that we use to find areas and circumferences of circles, D stands for the diameter of the circle. The diameter is a distance from one point on the circle's edge to a point at the opposite edge of the circle. R stands for the radius of the circle. The radius is a distance from the center of the circle to any point on the circle's edge. This means that the radius of the circle is always half the diameter. In our example, the diameter of this circle is 6 meters, and the radius is 3 meters. With this, finding the circumference and areas of circles becomes easy as pi. What is pi? Well, pi is that squiggly symbol. It represents an irrational number, meaning it never ends and never repeats. A close approximation can be made by substituting 3.14 or 22/7 in an equation involving pi. I've left here a nifty little video out of my favorites collection on YouTube entitled Mathematical Pi to help explain this symbol and where it came from. Now we are ready to find the circumference and radius of a circle. And here are a couple of examples of area and circumference problems using our previous example of a circle with a diameter of 6 meters. The circumference, C equals pi d, means the circumference equals pi times the diameter. So substituting 3.14 for pi and 6 as our diameter, the two of them multiplied together equals 18.4 meters. For area, A equals pi r squared, substituting 3.14 again for pi, times our radius of 3 meters squared. So 3.14 times 9 equals 28.26 square meters. So, where did pi come from anyway? Well, let's take a look at the history of pi, circles, and the correlation between circumference, diameter, and area. Pi and its association with circles was formally discovered by a Greek mathematician named Archimedes, who lived from 287 to 212 BC in the city of Syracuse on the island of Sicily. He published his proofs in a book titled Measurement of a Circle, which he submitted to the Library of Alexandria. This is according to Sarah Zannos from a book of hers she published in 2005. Measuring the perimeters of polygons just inside and outside of a circle, Archimedes was able to narrow the value of pi to between 3 and 1071 and 3 and 1/7. In decimal form, this is between 3.1408 and 3.1428, according to Mary Gow in a book she published in 2005. This seems an amazing feat considering the cumbersome form of mathematical notation available at the time. Ancient Greeks had no concept of zero or decimals, and their numbers were represented by the letters of their alphabet. This is according to Paul Lafferty in a book he published in 1991. As you can see, I have added here an artist's rendition of Archimedes at work and a diagram of how he arrived at his calculations for the value of pi, as well as a description of the Greek numbering system and some examples of how they did their math. Archimedes' discovery of the correlations between the diameter, circumference, and area of circles, and by extension the volumes of their cylindrical and spherical counterparts, allowed him to create engineering feats such as the Archimedes screw, a mechanical water pump that has throughout history been used for irrigation and more recently power production, according to an article in a periodical written by Nuremberg and Rores, published in 2013. And now for the uses of area and circumference in the present day. For the use of circumference in Full Sail career paths, let's say that a graduate of the sports marketing and media program is assigned the task of creating a banner or sign that wraps around an existing structure like a pole or a statue. This student would need to find the circumference of that structure, so he would know the length available for the signage graphic. My example is a cylinder with a diameter of 10 feet. So with the formula being C equals pi times d, again substituting 3.14 for pi, multiplied by 10 feet, we have a result of 31.4 feet. For the use of the area of a circle in Full Sail career paths, let's say that a graduate of the music production program wanted to put on a concert and was creating a temporary amphitheater with seating in a park. She would want to know how much area she had for equipment and the audience. In my example here, I have a half a circle with a diameter of 85 meters, with our formula being area equals pi times r squared, once again substituting 3.14 for pi, multiplied by 85 meters squared, giving us 3.14 times 7,225 meters, with a result of 22,886.5 square meters for the circle. But we're not done yet. We need to divide this answer in half because the space available is only half the circle. So 22,686.5 divided by 2 equals 11,343.25 square meters. This being a library research project, I conducted my research for this presentation both online through EBSCOhost's link on our FSO platform. I included here a screenshot of my research results, and also at my local municipal library, which I took a picture of while I was there and have included it with its contact information. I also attended several go-to training meetings for information and to ask questions about my research, APA formatting, etc. And I have included screenshots as well as the training ID numbers, which you could probably see if you blow up the pictures, but I included them below each picture so that you could see them easier. Thank you for watching my short presentation on circles, area, and circumference, and what pi means. Here you see my list of references, including our textbook for the class, Mathematics for Creative Professionals, found on alex.com, the Mathematical Pi song on YouTube and its link, the 3 books that I've found at the Physical Public Library, as well as the article by Nuremberg and Rores that I found on FSO.